For number 4, by what factor should the length of a simple pendulum be changed if the period or vibration were to be tripled? If you look at the formula for period, it equals 2 pi squared times length over gravity. So if you rearrange that to find length, you get t squared g divided by 4 pi squared. If t is going to be tripled, you'd put 3 where the t is, and 3 squared is going to be 9, so the answer is D. Number 5. The amplitude of a particular wave is 4 meters. The top to bottom distance of the disturbance is going to be 8 meters. Because if the amplitude is the height of the wave, of the crest, is 4 meters, but then you're doing the top to bottom distance, the crest and the trough are going to have to be both 4 meters, so the whole distance is going to be 8 meters. Number 7. Suppose a bug is jiggling up and down and swimming towards you at the same time. Compared to the frequency at which the bug is emitting waves, the frequency of the waves reaching you is higher. If the bug was just jiggling up and down and staying in the center, the frequency of the waves would be coming at you at just the same speed. But because he's swimming towards you at the same time, the waves take a shorter distance to travel to reach you, so that they're going to occur more frequently, so the frequency of the waves is going to be higher. Number 10. The kinetic energy of a bob on a simple pendulum swinging in simple harmonic motion has its maximum value when the displacement from equilibrium is at what point in its swing? It's going to be zero displacement because the kinetic energy is when the velocity is maximum. So the displacement from the equilibrium point is going to be 0 because that's when it's going to have its most kinetic energy. Number 11. When a sound source moves towards you, what happens to the wave speed? I thought it would increase because of the Doppler effect, but that's just the frequency of the sound waves are going to appear to me to be higher. It's really going to stay the same because the speed of the sound waves stay the same because you're in a fixed relative according to where the sound is coming from in the atmosphere. Number 12. Sound is an example of a longitudinal wave. Sound waves are longitudinal waves because particles of the medium through which the sound is transported, they vibrate parallel to the direction in which the sound wave moves. And that's what it means to be longitudinal, because the waves are parallel to the direction of the energy they transport. Number 13. As a gust of wind blows across a field of grain, a wave can be seen to move across the field as the tops of the plants sway back and forth. This wave is a longitudinal wave. It's a longitudinal wave because when the wind blows, the particles are moving back and forth, which is exactly what happens in a longitudinal wave. For example, if you stretched out a slinky in a horizontal direction, the first coils of the slinky are going to vibrate horizontally back and forth. The particles begin to move right and left, sending a wave because they're hitting each other and moving back and forth. There's like a longitudinal. Number 14. If you double the frequency of a vibrating object, its period is going to be halved. When I answered this question, I must have been thinking about wavelength, because if you double the wavelength, the period is going to be doubled, and that's what I chose. So the period will be halved because period equals 1 over the frequency. So if you double the frequency, like I did here with the 2, and then you have to do 1/2 times 1 over the frequency, so you get 2p equals 1 over the frequency, and 1 over the frequency equals p. So dividing by 2, you're going to get half of p. So the period is going to be half. Number 17. Constructive interference occurs when the crest of two waves overlap. It occurs when the waves come together, so they phase with each other, so that their oscillations at a given point are in the same direction. Their resulting amplitude is going to be a lot bigger, and that's what a constructive interference means. Like, the two waves of equal amplitude interfering are going to have twice as big as an amplitude because they're coming together and overlapping. Number 19. Which one of the following quantities is at a maximum when an object in simple harmonic motion is at its maximum displacement? It's going to be acceleration, not speed or kinetic energy like I thought, because speed at its maximum is going to be 0. It's going to be acceleration because when displacement is at its maximum, so is the restoring force. So because of F equals ma, when the restoring force is maximized, so is the acceleration. 21. You dip your finger repeatedly into water and make waves. If you dip your finger more frequently, the wavelength of the waves is going to shorten. This happens because the frequency is going to increase, but the wavelength is going to decrease, because wavelength is the distance of one wavelength to another, and because you're doing it more frequently, the distance is going to be shortened. Number 22. A cork floating in a pool oscillates up and down 3 complete cycles in 1 second as a wave passes by. The wave's wavelength is 2 meters. What is the wave's speed? For this question, I just got confused about what the frequency is. I thought it would be 1/3 because of the 3 cycles in 1 second, but really it's just going to be 3 hertz. So I had the formula right. Velocity equals wavelength times frequency. I just needed to do 2 times 3 hertz to get 6 meters per second. 23. A beam of light emerges from water into air at an angle. The beam is bent away from the normal. The beam's going to be bent away from the normal because when light passes from a more dense to a less dense substance, like from water into air, the light's going to be bent away. This is because light travels more slowly in a denser medium, so that's why the bending occurs, and that's why, because water is more dense than air, the beam's going to be bent away. Number 24. Equal wavelength waves of amplitude 0.25 meters and 0.15 meters interfere with one another. What is the resulting minimum amplitude that can result? I found the right answer for this one, I just must have circled the wrong one. I had to do 0.25 minus 0.15, and you get 0.1, so that would be B. Number 25. A skipper on a boat notices wave crests passing the anchor chain every 6 seconds. The skipper estimates the distance between crests at 30 meters. What is the speed of the water waves? For this one, I just used the wrong formula. You're supposed to use velocity equals distance over time, so you do the 30 meters over the 6 seconds, and you get 5 meters per second.